Okay, number 2 tripped me up because I wrote x instead of L for this equation. So now that I know that, solving for C of 0, you get 0, because when L equals 0, the whole equation just equals 0. Finding the first derivative of this equation gives you tan x over r, but that x is supposed to be an L. That's why I made this little note here. Sorry I did that way. Times secant x over r. Then the first derivative with plugging in 0 is equal to 0, so it doesn't really matter. The second derivative of x is 2 tangent squared x over r plus 1 times secant x over r. Then plug in 0, you get 0 plus 1 times 1 over r, which equals 1 over r. C to the third derivative of x is this long thing. I believe here is where I started to use a computer to help me calculate it, just because I didn't want to make a mistake between these things. And then plugging in 0, you get 0. Finally, the last derivative used, since it said to the fourth, is c to the fourth x. This might have been the one I used in computers, which equals 1 over r squared. Then you get c of x equals about this, but as I said before, x is actually L, so 0 over 0 factorial times L to the 0, so there'd be 0 over 1 times 1, which is 0, plus 0 over 1 times 1, which is 0, plus 1 over r to the 2 factorial, which is 1 over r over 4 times x squared, plus 0 plus 1 over r squared, 4 factorial, which gives you the final answer of this. Then for the next equation, it asks you to actually plug in values for both r and L, where r equals 6370, L equals x equals 100. It looks like I made a note of that down here too, which equals 1 over 6370 over 2 times 100 squared, because 100 is what was given to us. I'm just plugging them into these values up here, and that's supposed to be over 2 factorial actually. Plus this number times 4 to the fourth. It looks like I multiplied this one by 4 factorial already, to get your final answer of 0.784 plus 0.102 to equal 0.806 kilometers. If you kept adding terms, I'm guessing it would get to be about 1 kilometer, but I didn't solve it out, so I don't know. Last question asks me to find the radius and interval of convergence of this value, the series where k equals 0 to infinity of 2 to the k times x minus 3 to the k over k. To find this series, I'm getting mixed up. To find this interval, you have to use the ratio test, which is un plus 1 over un equals 1 over r. So this is where I wrote my equation. I noted that r equals the radius of convergence. I make these notes to make it easier to explain, and then forget why I put them there. So then, plugging it in, absolute value of x minus c is less than r, which is equal to the interval of convergence, which is negative r is less than x minus c is less than r, and then to get the x alone, you get negative r plus c is less than x is less than r plus c. I just did this to help myself remember interval of convergence, which is equal to I. So now actually plugging in everything, you get 2n plus 1, or 2 to the n plus 1 times x minus 3 to the n plus 1 over n plus 1 divided by 2n blah blah blah. It's just the same terms, not plus 1. Easier way to divide is to switch, so make it n over this and then multiply, which cancels out terms. You get 2 to the first times x minus 3 to the first over 1, which is the absolute value of 2x minus 6 being less than 1, which gives us, after we divide by 2, x minus 3 is less than 1/2. So our r is equal to 1/2. And then since our c is equal to 3, our interval of convergence is going to be 3 minus the 1/2 to 3 plus the 1/2, which is 2.5 to 3.5. So radius is 1/2, interval is 2.5 to 3.5.